Now see question number 8. If y is equals to log of x plus root x square plus a square bracket square, show that x square plus a square d2y by dx2 plus x into dy by dx equals to 2. Now this question from exercise 1.5, question number 3. So we write in solution y is equals to log of x plus root x square plus a square bracket square. Now we differentiate this function with respect to x first. So differentiate with respect to x. Now derivative of y with respect to x, we write dy by dx. Here we have to apply power rule first. So we write power in multiplication. So write here 2 into log of x plus root x square plus a square into derivative of this bracket, that is derivative of this outer function log. So we write 1 upon x plus root x square plus a square. Then we have to find derivative of this innermost function, that is derivative of this bracket. So here we have to find derivative of first term plus derivative of this root x square plus a square. So write derivative of x, that is derivative of first term, is 1 plus derivative of this root x square plus a square, derivative of root is 1 upon 2 root. So write 1 upon 2 root x square plus a square into derivative of this x square plus a square and in multiplication to this derivative. So derivative of x square is twice x and derivative of a square is 0. So here these 2 get cancelled. We write that as 2 log of x plus root x square plus a square 1 upon x plus root x square plus a square. Then here we write this as 1 plus x upon root x square plus a square. Because these 2 get cancelled, remaining is x, so 1 into x, we write x upon root x square plus a square. Now we cross multiply this. So write 2 log of x plus root x square plus a square 1 upon x plus root x square plus a square. And here after cross multiplication we get 1 into root x square plus a square as root x square plus a square plus x upon root x square plus a square. Now if you observe, this x plus root x square plus a square is same as root x square plus a square plus x. So in next step we cancel these 2 like terms. So we write here 2 log of x plus root x square plus a square into, here we get 1 upon root x square plus a square. Now see what we have to show here. We have to show x square plus a square into d2y by dx2. That means we have to differentiate this function. So before differentiating this function, we write this root x square plus a square to left hand side. So write here, therefore root x square plus a square into dy by dx is equals to 2 log of x plus root x square plus a square. Now we have to apply here product rule while differentiating the left hand side. So for removing this root, we have to take square on both sides. So write here first square on both sides, square on both sides, squaring on both sides. we get in left hand side x square plus a square, because square and square root get cancel here. Then square of this dy by dx is equal to square of 2, we write 4. Square of this log, so write log of x plus root x square plus a square, its bracket square. Now if you observe, this log of x plus root x square plus a square bracket square is the value of y. So we denote this as 1. So from equation 1 we write 4y. So write here from 1. Now we have the value x square plus a square into dy by dx bracket square. So differentiate with respect to x. Now we have to apply product rule. So write first function into derivative of this second. So derivative of dy by dx bracket square, we write 2 into dy by dx bracket raised to the power 1 into derivative of this dy by dx, which is d2y by dx2. So first function into derivative of second plus second function. So second function is dy by dx bracket square into derivative of first. So we have to find derivative of first plus derivative of second term. Derivative of x square is twice x. A is constant, so derivative of a square is 0. So we write 2x as derivative of x square plus a square. Then derivative of right hand side 4 into derivative of y, we write dy by dx. Now if you observe, in every term there is dy by dx. So we have to take dy by dx and 2 common. So we take 2 common and dy by dx common from left hand side. So 2 dy by dx we take common. So right here x square plus a square, we take 2 common, dy by dx common, remaining term is then d2y by dx2, plus we take 2 common dy by dx, so x into dy by dx is remaining, x into dy by dx is equal to this 4, we write 2 into 2 dy by dx, so this 2 and this dy by dx get cancelled. We get here x square plus a square into d2y by dx2 plus x dy by dx is equal to 2, that we have to show here. So we write the remaining term x square plus a square d2y by dx2, x square plus a square d2y by dx2 plus x into dy by dx is equal to 2, and which we have to show. So we write here hence proved. Now see next question. If y is equals to sine of m cos inverse x, show that 1 minus x square into d2y by dx2 minus x into dy by dx plus m square y equals to 0. So first we write given function y is equals to sine of m cos inverse x. Now differentiate this with respect to x. Differentiate with respect to x. So derivative of y with respect to x, we get dy by dx. Now this sine is composite function. So find the derivative of this outer function first. So derivative of sine, we write cos of m cos inverse x. Then derivative of this m into cos inverse x. Here m is constant and derivative of cos inverse x is minus 1 upon under root 1 minus x square. So we use here bracket. So write this is value of dy by dx. Now we have to find d2y by dx to here. So before differentiating, we rearrange the terms. We transfer this root 1 minus x square to left hand side. So write root 1 minus x square into dy by dx is equals to this m and minus sign, we write minus m into cos of m cos inverse x. Now again we have to differentiate this function with respect to x because we require d2y by dx2. So differentiate with respect to x. Now in left hand side we have to apply product rule. So we write first function So first function root 1 minus x square as it is into derivative of second. So derivative of dy by dx, we write d2y by dx2 plus second function, that is dy by dx into derivative of first. So here root, so derivative of root, we write 1 upon 2 root. So write 1 upon 2 root 1 minus x square into derivative of this 1 minus x square. Derivative of 1 is 0. Derivative of x square is twice x. So 0 minus twice x, we get minus twice x as a derivative of this 1 minus x square. So first function into derivative of second plus second function into derivative of first is equals to, now here m is first term minus m is first term. So we have to find derivative of this cos. So derivative of cos is minus sign. So write here minus sign of m cos inverse x into, now we have to find derivative of this m cos inverse x. So write here m into derivative of cos inverse x is, we write here in multiplication or in bracket, minus 1 upon under root 1 minus x square. To eliminate this root 1 minus x square, we multiply to each term by root 1 minus x square. So after multiplying by 1 minus root 1 minus x square to first term, here we get root 1 minus x square its square. So square and square root get cancelled. So we write here 1 minus x square its bracket square. We multiply each term by root 1 minus x square. So here we get root 1 minus x square its square into d2y by dx2. Then plus, here after multiplying by root 1 minus x square, this root 1 minus x square get cancelled. So remaining is 2. So we write here 1 by 2 dy by dx, or you can cancel this 2 with 2. So we write here plus minus minus. So write here sign as minus, remaining term is x. So minus x into dy by dx. Then here in right hand side 1 minus 2 minus 3 minus, so 3 times minus sign in multiplication. So we write minus sign. So this m into m, we write m square. So write minus m square is equals to minus m square. Then sin m cos inverse x, sin of m cos inverse x, and after multiplying by root 1 minus x square, this root 1 minus x square get cancelled. So we require y here. So this given value we call 1. So from this equation 1 we replace this sin of m cos inverse x as y. So write here square and square root get cancelled. So write 1 minus x square into d2y by dx2 minus x into dy by dx is equals to minus m square into y. So we transfer this minus m square y to left hand side. You write here reason from 1. Therefore 1 minus x square d2y by dx2 minus x into dy by dx plus m square y equals to 0, hence proved. So in this way you try the remaining questions with the help of the solved questions.